demonstrate how everything is working in my data set, and there's some very interesting mistake how I made in the syntax, but it's not, even though it's not about data, but I think the syntax is also very interesting for you guys. So everything is basically import the data. So one thing to mention is this GDP I found on this website. I'm not sure if you wanted me to cite to codes or put a reference in. Please let me know. And then and the trend data already did some pre-cleaning in R, and I put in Python right now. So let's look at it. Here, so this is the date. So the GDP, this is what GDP looks like in the original way in the first place. So this is has the date. So each year they collect the GDP 4 times. So it's not by year, it's actually by seasonal. This is a seasonal GDP. So I will actually combine them by the year at the end, and so just tell you all the data type of these are strings. They're not date. It's not float or double. And then this trend data, you'll actually look at here why there are some nulls like NAs. So in original Excel, the rows are only go to till 57. Yes. So before that are all data we need, and after that is basically white space and some other comments. So that's what I did. I only picked the part we need. So this is the data set. So but you see here year has a weird 0.0, and these are all even though they're integers, but they all have a 0.0 in there. So what I did is first I make the GDP name, the column name into from date into year, and let's see. Yeah, so right now it's called a year. It's not the date anymore. And so what these things do is basically innet is another way to index the entire data set. So what this do is innet the first column. This is the for loop is about, and then pick up the first thing, which is the year, and then let it equal to the. I also slice the string. So remember, this is a string. I also slice it to pick out the year. And this and the second code is basically make these things like a double or float. These things. Yep. And for the trend data, this is what I do is basically did the similar thing as for the year, and then make the other two things at the double. And then let's do this. Let's take a look at it. So yeah, right now it is pretty much clean. So yeah, so then we can start using it. So after that, I did I did a group by. I add these 4 numbers together according to the year. So yeah, you can see right now it's according to the year. It's not seasonal, and this is what I want. And then I realize in a GDP this is only like 100 trillion, I believe, or $billion. I don't know what's the base is. So I'm assuming this is billion. So yeah, you can see in this year it's only in the GDP. It's only that little, but in the year of 2021, year 2022 is that much. If we what I want is to analyze the economics, how economics impact the mass shooting case. So if for say if we in this year we have a one mass shooting case, and in 2022 we also have one. That doesn't tell us much thing, because the GDP are exactly are not are extremely different, but in the shooting case are same. So I don't want that. So what I do is I create the growth rates and I calculate the growth rates. So yeah, so basically I calculated the growth rates. Let's take a look at GDP right now. So right now it has the growth rate, so it's yearly growth rate. So from year 1948, it has the growth rate of this number, and so yeah, just basically growth rate of a GDP each year. In the final table, I what I did is merge them two, is use a inner merge, and on year. So this is why I changed the column name from date to year. After that, look at the final table. Yeah, we finally got all these. So each in the final table, I have a year, I have a GDP, I have a growth rate, I have each year. This year's like total murder numbers, shooting cases, mass shooting cases. So we finally can do some analyzing. And this is what I got. So I did try to put them in different columns. So this is how I look. Put in a X column. This is how I look in a Y column, and you can see according to well, I did Google the golden angle or golden. I don't I don't sorry, I forgot what's that called, but golden graphic or something like that. So this is basically, yeah, you can tell the difference from if you make a x equals to growth rate and a y equals to the shooting cases. You cannot find any particular trend, but in here you do, like a, according to the picture, you can find a downside trending. So which is, you know at this point, when the growth rate is over 10, there's a year that growth rate is over 10, and there's only one mass shooting case. But there's also years when the growth rate is around 0 and the mass shooting case is 7. So according to this picture, my conclusion is that the how fast the economics is developing will affect how many shooting cases like have in that year. Because if the economics development is great, every people is happy, every people has a job, they will just probably go to work. But if there are a lot of unemployment and the people are mad, people are upset, so they probably will do something extreme. There are violent. So yeah, and according to that, I also analyzed the crime, which not actually crime, it's the murder. So for this one, I don't think it makes much difference if I make the x and y. I switch the x and y, and then let's actually see. So but my conclusion under this graph is the thing doesn't that tell you that difference, even though you know there is a trend actually. So when the growth rate goes up, the crime also goes up. I actually personally, I think it doesn't make sense. So that's why I didn't really use this one. And there are also some outliers. So um I don't think there is a correlation. Or there is a strong correlation between the developments, like the economic developments and the crimes. Okay, so yeah, that's all my Friday presentation, and please let me know if any questions. Thank you.